Alrighty. Hi, everybody, and welcome in. We're going to be hearing from Himanshu today on unlocking real-time news recommendations, the power of graph relationships in Neo4j. And I will go ahead and hand it over to you, Himanshu.
Thank you. Hey everyone, and welcome. My name is Himanshu Agarwal. I'm a machine learning engineer at Glance. Today, I'm excited to share how we are using Neo4j to tackle one of the biggest challenges in content delivery, providing real-time, relevant news recommendations to millions of users. This is AI-powered knowledge graph project that was motivated by the challenge of fast-moving news teams and the need to deliver personalized, engaging content recommendations on Glance platform. So a little about me. I'm a machine learning engineer at Glance, where my team focuses on using AI to understand content and personalize user experience. My background is in building large-scale machine learning systems, particularly for search and recommendations. I've always been fascinated by how we can model the world's complexities, which naturally led to graph technologies. I'm thrilled to be here at Nodes to talk about how we are putting graphs into production. A little session overview here. So we'll cover how Glance enriches raw news articles using large language models, constructs a graph of related content, identifies emerging trends, and finally serve real-time recommendations. And how these pieces will fit together into a high-performance system for personalized content discovery. Now, for those unfamiliar with Glance, we are a platform that transforms the lock screen of your phone into a smart lock screen. Instead of a static wallpaper, users get personalized content, news, entertainment, sports, updates, and more. We are present on more than 300 million lock screens because we operate on a lock screen. Our window of opportunity to engage a user is just few seconds. This means our recommendations have to be exceptionally relevant and timely. Glance also provides a scrollable content feed experience for the users to consume their preferred content, where news articles are a major contributor. We have an in house editorial team as well and a content management system which manages through these daily load of more than 50,000 news articles. And now let's discuss about the problem at hand. Every day, the world produces a staggering amount of news. At Glance, we process over 50,000 articles daily from all over the globe. This presents a huge challenge. Traditional content discovery methods often struggle because news has a very short lifespan, and relationships between articles are incredibly nuanced and complex. How do you connect a local political development in India to a global economic trend in real time? And if you don't, the users will never be able to understand the larger picture. To serve related news articles to each news and glance feed, the core problem we faced was twofold. First, the context blind spot. Users sees headline, but they don't understand the underlying connections. Crucial context was being lost. Second, our legacy system suffered from a semantic failure. Simple keyword matching is blind to meaning, and even semantic matching using text embeddings doesn't always help. And it was failing to see the important relationships between stories. We knew we had to do better. At this scale, the need was of an automated intelligent system to surface contextually relevant stories. And this is why we built a content knowledge graph. So, sorry, yeah. So, the solution to our problem is a three-part strategy. First, use large language models to truly understand the unstructured text of each article. Second, use Neo4j to connect this information into a rich graph of knowledge. And third, build an API that can serve these insights to our users by simply walking the graph. By modeling articles, topics, entities in a graph, we capture semantic links. We capture semantic links explicitly. For example, if two articles mention the same person or event, graph connects them. This lets us traverse from one news node to related nodes through shared entities. Transforming these articles into a knowledge graph makes content understanding a graph traversal problem. This overcomes the silo problem and lets us run real time pattern matching queries for recommendations. So let's take a look under the hood at the architecture that makes this all possible. So this is how we turn the fire hose of unstructured news into a web of connected knowledge. So this diagram illustrates our content pipeline. Raw articles are ingested and normalized. An AI layer using Gemini foundation models via Vertex AI extracts entities, generates embeddings, and classify content. Finally, this enriched data is written into Neo4j to build the graph. Each article flows through stages of ingestion, NLP processing, and graph update in an event-driven system. The graph nodes represents articles and entities, and edges encode the relationship. So, getting into a more details here. So, it all begins with the ingestion. We pull in over 50,000 articles a day from a global news feed, from all the global news feeds, and these immediately enter a message queue, which is a critical design choice. It decouples our ingestion from our processing, making the entire system scalable and resilient to spikes in news volume. So once the article is picked up, it undergoes a two-pronged analysis, almost like using two different parts of the brain. The first most important context is the context is the knowledge brain. We send the article to Google's Gemini model. This doesn't look for similarity, but it extracts structured factual knowledge. It performs named entity recognition to find the people, companies, the standard IAB classification of topics, which is used industry wide. It extracts key mentions and generates headline or topics at a generic as well as at a granular level. This answers the question of what is it all about, who is involved, where it did happen, and why is it significant. Second is the semantic brain, the topmost path that you see. So we use a Vertex AI embedding model to create a vector representation of the article's content, the generated topic and headline. We then use the vector search to find the most semantically similar topics and headlines that are already existing in our system. This kind of refines and generalizes the answer to the previous question, that is, like, what is the article generally about? And it helps us find right conceptual neighborhood for the news piece of content. So after this, the Neo4j part comes in. Now we join everything together in Neo4j. The structured data from Gemini allows us to add relationships. We create an article node and connect it with the explicit relationship, just like you can see here. So yeah, sorry. Into explicit, we can create article nodes and connect it with explicit relationships like mention entities or hash topics to the existing node in our graph. We are not just saying two articles are similar, we are defining precisely how they are related. So finally, this living breathing knowledge graph is queried in real time, and uh, with the fast graph traversals, we can instantly find connected storylines. We can identify trending entities and power the personalized feed you see on the user's devices. This processing of news articles happen throughout the day, as and when the article is ingested in our content management system. However, the flow to serve these connected insights to user happen with like sub 100 millisecond latency on the query side as soon as the user engages with the news article. So moving forward, these are like two steps of the solution that I already discussed. And after all the processing, this is how a single node looks like. We can see the news about Kolkata weather warning, and you see the location, topics, IAB category, etc. here. If you look at the hashtags connected to the node, you see a lot of information from that alone. and such informative nodes are connected to all the related articles. You can see so many articles right now that are connected throughout the months, that are connected with the same hashtag. So what we can do with this graph, it powers four key features that I already mentioned. We can provide true entity aware similarity. We can generate intelligent storylines that track a developing event. On that note, like the generic generated headlines that I was talking about, they are connected to multiple news articles related to that news. So we regenerate those headlines as story progresses and the news articles are attached to it using semantic similarity. So, for example, a generic topic might start off as heavy rains in Kolkata and may develop over time into a disaster warning due to heavy rains in Kolkata, right? And we do this development of the headline throughout as and when the new articles are coming in and getting ingested with the same generic headlines. So the system provides like live connections, surfacing breaking news next to existing stories, and the most powerfully, we can uncover hidden connections. For example, we can link merger announcement to a profile of a new CEO, to a story about the wider industry, and finally its impact on the stock market. A journey impossible to track and trace with keywords alone. So this is sort of how the magic happens with the related content. To find related articles in real time, we don't need to compute vector similarities. We just ask the graph. Cipher queries demonstrate the logic. Starting from source article, we find the topic, tag, entities it's connected to. Then we find other recent articles that are also connected to the same node. And we take the overlap of the connections based on tags, entities, to score the articles better. So I'll move forward a little faster because we are have a less time now. Let's look at this practical example. Again, this is similar to what I've described. The two articles can mention about different things, maybe related through different entities. For example, these two articles here, one talking about chips and one talking about the new iPhone, may be related because of the company Apple, that are related to both. Um, yeah, so trend detections and analysis, the knowledge graph isn't just for pairwise recommendations, it's a dynamic map of how topics are evolving. We track usage of entities with sudden spikes, connections to person and events, and external trend indicators. If the product launch causes many articles to link to Acme Corp, for example, our system flags it as an emerging trend. You can see a lot of trends from these screenshots are from today from the dashboard, and we can see like a lot of trending news about India winning the World Cup, and then NYC mayor elections, right? And similarly in the entities, you can see the most popular entities, trending entities right now in form of Donald Trump and Narendra Modi, etc. uh, an important part of this entire project is the engineering at scale and speed. So, to handle 50,000 articles per day, we made a pipeline fully asynchronous with Kafka. This got like 4x throughput improvement. In Neo4j, we analyzed real usage pattern to create targeted indexes. This drove query times down into 50 to 100 ms range. We also implemented multi-tier caching, and uh, critically, we didn't try to be smart on every article. Instead, we focused resources on top 20% of the articles that drive 80% of the user engagement. And this strategy, combined with caching, pushed our recommendation coverage to above 85%. So, like the impact that was visible was on our user engagement into the number of swipes, the content that was served to the user, and the consumption of the users. And you can see the metrics here definitely. To sum up this talk, um, the most important key takeaways from this project was that the power of Neo4j, the power of LLMs, and system design together is very important. The prompt tuning and tuning of the indexes in Neo4j helps a lot. Uh, So Glance now has a content intelligent engine that makes every user glances more meaningful by surfacing contextually connected stories. We hope these strategies serve as a model for other platforms grappling with the information deluge and seeking deeper content connections. So we don't have much time left, but if there are questions, you can reach me at these places. And you can read more about this work at the two different blogs that I've mentioned here. Okay, we have questions here. So cost of LLM and performance and latency. So as I mentioned, the performance and latency part was solved with a lot of system design efforts, a lot of caching, better tuning of indexes, configuration of Neo4j indexes, and better cipher queries that led to a lot of performance improvement. And the cost of LLM integration, that depends on the volume of the content that you have. So for us, like processing 50,000 articles daily was very expensive, but we do use a lot of good prompt tuning and prompt engineering to do better work with smaller models. For example, we use Gemini Flashlight, and it does a lot of work for us, not directly, but with a lot of prompt engineering. You can get done with a lot of small language models as well, which are very less expensive. My contacts are visible right now on the screen, I hope. And classification of news articles and content is relevant to the user because article title, description, long text. Okay, classification of the news article is done based on the like industry-wide used IAB classification system. It has like about 700 hierarchical classifications, and it actually needed. See, this could be done in two ways. You can train a classifier over 400, 700 classes and try to classify your news articles, or you can do a very good prompt engineering and give like small information in a better manner to the large language models to do so, because training a classifier over 700 classes is also not an easy task without any pre-existing data. So we went straight with IEB classification because that is like industry-wide standardized classification that is used, and we are classifying all our news articles across globe, across languages using that. So that gives us like a good distinction between the different themes, different topics that we are serving. Uh, how do you store core data content in the knowledge graph or an external DB? Core data content is stored in a different external DB that is there along with us. Knowledge graph only stores about the metadata that we have extracted and certain other information, certain other metadata like its publishing date, publishers, and other things. But the core content is stored in an external DB. How is user modeled in the graph for recommendation? Right now, user is not directly modeled in the graph recommendations. How we are using this system is like we are seeing when and how user engages with certain content, and we are providing related content to that. In this process, we are also gathering a minute level user preferences from those articles. So, for example, if you're engaging with an article which has a lot, like five different tags associated, two different topics associated, locations, entities. So, I'm getting a very minute level of understanding about your preferences. And with more articles you engage, I can boil down to what exactly do you like, right? And I can serve you better personalized recommendations from others models as well. So it is not like that the graph or these metadata enrichments are only used for related articles. Like user can be modeled in different ways as well. Thank you for all the comments. How do you manage overlapping clusters in fetching relevant topics? We don't. The overlapping clusters is the key to related articles actually. So the more the overlap between topics, between entities, between tags, more we know that the articles are related closely. All the information in single graph, or are they separate knowledge graphs? Right now it is a single knowledge graph which contains all the news uh, across globe, although we have different keys in the metadata that are associated with like publishers, country, language, using which we can differentiate the maybe like where are we serving and who are we serving to within the cipher queries. So I don't think there are more questions here. Thank you for being such a good audience and for such good questions and your comments.